Hello friends, in this video we will discuss about the multicast routing protocol. Okay, so let's start. So in the previous few decades, many protocols have been emerged as the multicast routing protocol. Some of them were originally created and some were the extension of the already created unicast routing protocol. So we can divide all these protocol on the two bases which we have discussed, the source based tree and group shared tree. So for source based tree and group shared tree. Okay, in the source based tree, one is the example that is based on open shortest path first. Open shortest path first, and the second one which is based on the multicast distance vector. Multicast distance vector. Okay, and the name of protocol used in this is the MOSPF, and the name of protocol used here is the DVMRP. Okay, and for the group shared, there is a very important protocol known as the CBT, core based tree, and there are the some protocol that are based on the PIM concept. We will discuss it later. One is PIMDM and one is the PIMSM. So PIMDM is based on the source based tree, but the PIMSM is based on the group shared tree. And there is also a concept of the next concept of the M-bone. So in this video we will discuss about these three things: MOSPF, DVMRP and CVT. And in the next video, which is basically dedicated to M-bone, we will also shortly discuss about this PIM. So this will in the this video and this will in the next video. Okay, so let's start with the MOSPF. So what is the MOSPF? In the previous module, there was a concept of the OSPF. So that was for the unicast. Okay, so if you haven't refer that video, please go refer that video, watch and then come here. Okay, so it is only extension of that, so it can be, and its full form is as the multicast open source, not open source, open shortest path first. Okay, for this protocol a packet info is required. A packet info is required for associating the unicast address of the source or host with the multicast address of the group destination destination. Why the unicast? As it is the extension of unicast model, so it is uh, more about dependent on that unicast address. And This information is maintained by a packet which is called as the group membership LCA. Name is important. Group membership LCA. Thus, what we can do, if there is a group and there is multicast router, these are the another groups. So if one host want to send some message, then rather than passing the group address of this, we can simply pass the unicast address of this source. Unicast address of this source. Okay. And for and when the tree is maintained, that shortest path tree is maintained by using the Dichatra's algorithm, which was also included in that OSPF. That in that model also the trees were maintained with the using the Dichatra's algorithm. So here it is same. Okay, and one benefit here it is that once the tree is created, once the shortest path tree is created, it can be stored in the cache for future use. Future use. So that was all about the MOSPF. For better understanding, I will recommend that please first understood the OSPF and then come here. These are some only extension, not much. Okay, now comes to the DVMRP. Okay, so let's start about the DVMRP. So the DVMRP, the full form for it, the distance vector multicast routing protocol. Distance vector multicast routing protocol. It is simply based on the distance vector, means something that is related to that how much is the distance between one router to another. Okay, so first concept is the flooding. Flooding means if I take an example like this. So if this was source, then flooding means it will send the packet here and also here. Then what this R1 will do, R1 will send the packet to all its connected device. If let's say it was also connected, then it also sent here. And R4 will also do the same thing, that it will send here, send here. Then as if these two are connected, R1 and R4. So R1 have sended the data or the packet to R4. Then what will R4 do? R4 will do to other connected routers but not R1 reverse. Means from which the router have accepted the data will not resend to it, but send to all other connected devices. devices. Okay, so it means, let me clear here. Okay, what does it mean? It means that if R1 receive 4 data packets, then it will send to all the 4 data packets here and here, but not here. If R4 total get the 5 data packets, then it will send to here, but not here, but not here. If it have received data from here, yeah, then. Okay, so that was all about flooding. Then there is also multiple duplication and multiple looping. Does not the infinite loop, as it is not sending back again from which it has received, although there are the some looping. In order to overcome that, here is a concept of the reverse path forwarding. Okay. Reverse path forwarding. It means it will send only those data packet which have traveled only the shortest distance. Shortest distance. And how it will get? It will get this info from its database, has been which has been multicasted and have been saved along with it, that what is the shortest distance between a specific router or device. Okay, so it means if a source send a data, this one, it will receive it and forward it here and forward it here. Okay, then R2 will receive the data and then forward it here, forward it here. Then R3 will receive the data, forward it here, forward it here. Okay, and in the same manner, if we see that source have transferred this data to here, then it go here. So it could be transferred here, but it haven't. Why? Because the shortest path was from this side, so it has not been transferred here. Okay, so the shortest path was from this side, so it has not been transferred here, and something in the similar manner not transferred, it has not been transferred like this, it have been simply transferred like this. Okay, so it is only for the that transfer only those packets which have covered the shortest distance. Okay, I hope this thing is clear to all of you. Next thing, that is the RPB. Okay, clear it. Okay, what is RPB? So RPB is simply the reverse path broadcasting. Reverse path broadcasting. There was a problem in RPF that one hop or host may receive the multiple packets or multiple copy of a packet. But here we have created a parent child relation. Let's say that N3 is parent of R2. Something there is R2. Sorry, not parent. N3 is child of R2. Then the N3 will receive only packet from R2 but not from R1. Not from here. And what was in RPF, it was receiving the packet from R1 and also from the R2. But in reverse in the reverse path broadcasting, it will receive only one copy of a packet. Okay. And there was also problem that N3 doesn't want to receive any packet, but as it is broadcasting, R1 is broadcasting, R2 is broadcasting, so it have to receive. Then there is the another concept, reverse path multicasting, in which this child node can send a request that is pruning and grafting. Pruning means now I am pruning from here, I will not receive any packet. So no any packet will send to here. And if again it want to receive the packets, then it will send the grafting message and it say yeah, now I am open to receive the message. Then this R1 will send a message or packet of the data to it. So these were all the concept of the distance vector multicasting routing protocol. Okay, now let's see about the core based tree formation or core based tree protocol. Okay, so let's see. So this tree is no named so that core based tree because here the tree is formed by using the center core router, that is also known as the another name for it, let me recall. I am forgetting the spell of it. I think it is like yeah, Randazios router. So it is another name, although we are commonly using that core common router. So what is happened that source unicast the message to this router only. That is the core center router or the Randagious router. Okay. And this held a list of the shortest path corresponding to the every group member or groups. Okay. And according to that, this router then send the data to the different other routers. And this thing we have already discussed when we were discussing that shared tree. So this protocol is simply based on that. Okay, so that was it is. Now I am ending this video. In the next video we will discuss about the PIM protocols as well as the M-bone concept. Okay, thank you. Bye bye. Take care.